Hi, so in this we're going to talk about conditional probability. So as when we have two dependent event, so we can create this kind of probability in them. So let's suppose for any two event A and B, such as that the likelihood of B occurring is greater than 0, that means probability of B is greater than 0. So the conditional probability formula state as following, that probability of A given B has occurred, probability of A intersection B, or probability B. So the above one is the probability of the intersection, and probability B is the probability of event B. So to understand this, you can we can take an example. Let's suppose we have to reach out to purchase, let's say, a mobile phone from a shopping complex. So we went for to purchase a mobile phone, and based on the mobile phone, we want to purchase the mobile cover as well as body cover. So what is the probability of getting the body cover of a mobile phone based on the probability of purchasing a mobile phone? So this is if we do a vice and versa, like if we went for purchase a cover and we get the same size of mobile phone, is the conditional probability for both. So if I talk about the intuition behind the formula is that only one intersected in the outcome where B is satisfied. Only the elements in the intersection would satisfy A, as well as it is parallel to the favored overall formula that intersection is equal to preferred outcomes, and B is a sample space. We can also remember few points that unlike the union or the intersection, changing the order of A and B is the conditional probability alters its meaning, as I discussed. So probability of B on A is not the same of probability of A on B. So even if probability of B on A is equal to probability of A on B numerically, the two conditional probability possess different meaning even if they have equal values, right? So in order to understand conditional probability, let's do one example that gives us the more good idea. So let's suppose in a group of 100 sports car, a buyer bought around 40 alarm system car out of 100 sports car. 40 have alarm system, 30 purchase bucket seats, and 20 purchase the alarm system and bucket seats both. So out of 100, 40 have alarm system, 30 have bucket seat, and 20 have both. So if a car buyer chosen any random bought an alarm system, if car buyer chosen at random bought an alarm system, what is the probability they also bought a bucket seat, right? So this is the condition where we can apply our condition probability, and that is nothing but let's do by process. So since we know the formula of probability, conditional probability is based on our conditions, and that is nothing but, let's suppose you have out of 40 alarm system, let's suppose we have 40 alarm system car, and 20 have both, right? So we will find out in the very first step the probability of alarm system, that is nothing but 40 by 100, so that will become 0.4. So let me tell you, so this will be nothing but 40 by 100, so that will become 0.4. In the second step, this is the probability of alarm system, right? And the second probability, that is nothing but probability of B, you can say that, let's take it as A because it's an alarm system, right? So that is nothing but 0.4, and probability of both will be is nothing but 20 by 100, so that is nothing but 0.2. So we know better, intersection is 0.2 and that is 0.4, it will become 0.5. So this is 40, this is the bucket seat is 30 and 20, right? So this is how we can understand that the condition probability will become 0.5. That means the probability that a buyer bought bucket seat given the purchase and alarm system is 50%. I hope you understand.